Hi everyone! If you have ever tried to measure a distance or locate an object in a room using a Bluetooth or Wi-Fi, you already know the problem that can arise and how they can become truly frustrating. I myself, in my early years as a freelancer, had the brilliant idea of taking a contract for a positioning system for a digital museum using Wi-Fi triangulation, and let's say I had several problems. The RSSI jumped constantly, a satellite seeker was annoyed or a person passing in front of the sensor, and the reading could even be off by meters. Basically, turn on a light when you enter a room, it might be okay, but for robotic or precision tracking it's certainly a technology that needs to be reconsidered. But luckily today Ultra WideBand technology come to our aid. This basically significant change the way this distance is calculated. It's no longer based on signal strength, but calculated the time of flight of radio wave. Basically it's like having a stopwatch that measures the speed of light. The result obtained is a precision to the centimeter, and the most interesting part is that today a base device costs about 20 €, less than a pizza and a beer, which undoubtedly the satisfaction is not the same, but it's certainly a low price. Think about it, even a giant like Amazon, to prevent its robot from colliding, must use a mix of LiDAR, cameras, QR code on the floor, and so on and so forth. With Ultra WideBand, all this becomes incredibly simple. Those who follow Mischianti know that I refuse to talk about theory if it's not applied on concrete result, it's not rigid. So in this video we will take some Ultra WideBand modules, in our case the Reyax RYUW122, and we will see how to connect them to devices like ESP32s and 5V Arduinos, possibly without burning them. To use this device I write a library that simplifies their use, in the style of other ever already written, and that probably some of you will also use. But above all, I would like to go beyond the simple calculation of distance and analyze what could be the possible architectures for a complete positioning system. In practice, beside the standard one, which is what Gemini or ChatGPT also suggest, if you ask them, that is the famous 3 fixed anchor at the corners, calculating the distance of a tag and then sending everything to a central server that triangulates it. This is all very nice, it's certainly perfect for Amazon, but just as certainly not very suitable for a management, let's say, a bit more domestic. And then another, let's say, infrastructure that I thought of for a bit more human use, that could be defined as a reverse architecture. The one where the anchor acts as the tag and basically manage on its own and triangulating its own position. So no more server, no PC turned on, no messaging system, and so in practice the robot goes to calculate its position autonomously. Okay, so we can go see the modules and create something more concrete. Let's now go see the device. Let's start from the Pinout. Here is it. There is a 3.3V input for power supply. The reset pin will serve for more than anything else to synchronize the serial's interface, the input and output of the serial. And output pin that signals the status of the device, that is, if it's high, it's normal, it's low, in sleep mode, and finally there is the ground. The connections are quite simple actually, because you only need to consider the serial reception transmission, the ground and 3.3V power supply. Then only precautions, as you can see here, is that to transmission of 5V device either you apply a voltage divider, otherwise you risk burning it, or you can use a logic converter. Let's say that the best solution is always to use a logic converter, because it's handles the conversion of all the input and output signal. While for devices that are 3.3V, the connection is really simple. The only precaution, as you can see, is that the reset pin is also connected, because on ESP32 device, apparently to synchronize the transmission is necessary to set also this pin. Then, if you go to use what is my library, you will see that it's quite simple. You simply need to to set what is the construction with the transmission pin and serial reception pin, the serial you want to use and the reset pin. So basically, as you can see on the pinout, the 16 and 17 that I used are already in reception and transmission. The only thing is that on core 3 often the spin varies, so it's always better to set them in the same way. Well, this is the C3 and so on. You can find the library, but anyway you can install it directly from what is the Arduino library manager. You just need to write RYUW122 and there are a couple. Maybe if you want to follow the tutorial, take mine. Then well, this is for the setting inside platform and this is the basic example. Basically, it checks the correct wiring. Now maybe we can go see. Let's see. For this case I have this one already ready that I used for other purpose. Done. Okay, anyway you see I can also maybe adapt for the Arduino Mega, another construction for the Arduino Uno, which however as you can see is a software serial. For software serial, you need to have a small precaution. The basic device anyway is at 115-200 baud rate. If you want to use software serials, you have to set it to 9600, but what is the problem? First, you have to connect with another device to the device specific baud rate, change it to 9600 and then connect the software serial. But now let's go to see. Let's upload. All check were successfully. Well, now let's go to see a simple example in action. That is the mere calculation of distance with the exchange also of a short message. As I explained to you before, the anchor pulls the tag and the tag response also including the time it took for the calculation of the response itself. Therefore, making the difference between the time for the start sending to the reception of the response minus the time for calculation of the response, you can manage to get a very precise value. Let's take the sender sketch, that is the anchor. We put it in our C3. Then we will also go to see in detail the various sketch. Let's take the tag. Okay, and we will put it on Arduino Mega. So for Arduino Mega, I have to adapt the constructor. Okay, we'll see better after this sketch. So apart from the constructor, which we also talked about earlier, and can also be easily seen in the documentation, the relevant part are 1. Set the anchor mode, set network ID specular for boot, anchor and tag, and then put the address for anchor. Actually, the communication inside the API is implemented in 2 modalities. The first is synchronous, that is, the anchor sends the message to the tag and wait for the response from the tag. Unfortunately, this one is much more convenient, but is a blocking procedure. Consequently, for embedded programming in particular, it's always not recommended. Our microcontroller friend should always have a continuous flow inside the loop to be able to do all other operations, surely. It's convenient because you send, wait the response and then process the response, but it is not the optimal solution. Basically, I always use the asynchronous mode. The anchor sends the message to the tag and then continues the loop. The cycle inside the loop to receive the response a callback is set. Here, this is on anchor data received. On anchor data received, Basically, the tag address will arrive. To understand which tag is responding, maybe you have pulled multiple tags and are waiting for multiple response. The length of the payload, which would be the little text that can be inserted inside the message, but it's really short. Then there is the data, which is the real message, and what interests us is the distance in centimeter and the RSSI, basically the distance we need, because to do a triangulation this distance must be handled, and the RSSI in case we are moving too far away from what is the tag and we are losing the signal, if the signal is too weak, if there are interference, whatever else. The tag actually is even simpler because it has practically no logic. It simply needs to be set to tag mode, the same network ID, set the address, and here too I put a callback that intercepts when the tag received data. Everything inside this on-tag data received is practically useless for the correct function of the device. Now, here I put them more than anything to have a log and show that is communicating, it is responding. Even the tags and data is irrelevant. The only utility is that you can attach in response a small message that maybe can useful for various reasons, to pass maybe simple data that are used for more extensive use than just communication. All this response logic is already handled by their hardware. Now, let's proceed to the upload. Let's start from the ESP32. Okay, upload done. The anchor configure starts sending ping to the tag, but no one answers him. He stands still there. Now, let's switch to the Mega. Now the Mega is also loaded, and you see it has already received messages from the anchor. This is the famous log that had been put inside the tag callback, that basically is useless. But we needed to have a confirmation, and he responds back with the text pong, and here he received the data, the message, the text pong, the distance, and the RSSI. Now, as you can see, they are practically paired. If started to move it away, here the distance lengthness. Well, I would say that for today we have put an automator on fire. We have seen that what Ultra WideBand is, we meet the Reyax module, and fundamentally we understood how to connect it and make it communicate with each other microcontroller without casing the image. The base is there, the data pass, the module talk to each other, and the precision is the promised one. However, before closing, I want to be honest, consider this video as a bit of pilot episode. I'm experimenting with this new format of technical dissemination of my contest, and I don't hide it from you. Let's say that I feel a bit needling to be run like a periodic gear. Precisely for the reason your feedback is worth double. Let me know if you like this practical cut. I realize that the rhythm perhaps need to be improved, but I would like to understand if there is interest in seeing this kind of content. For my side personally, I prefer to read technical documents and the like, so I still need your feedback anyway. In the next video, we'll take this base and build in the actual architecture. We will see how to create the corporate tracking system, and above all, what I prefer autonomous navigation for the robot. So tell me yours, we'll see you in the next video. Hi everyone, and thanks for watching.